Welcome to this video. We will be discussing network structure in more details. In the previous video, we have seen different aspects of structures by examining how a certain node is different from other nodes in the network in terms of its average length, shortest path length to other nodes, as well as the number of cliques it happens to lay on. In this video, we'll talk about two aspects of structure. We will talk about the structure of the network overall, as well as the individual positions of different nodes within the network structure. We're going to use the Apollo movie network as an example. When we look at this network here, we can see that there are 5 nodes in this network, and those nodes are different in terms of their positions. We can see that the node representing Gary Sinise, for instance, is much more central in the network compared, for instance, to Ed Harris and Kevin Bacon. We can also see that some nodes form a clique of size 3, for instance. The network itself overall is a small network, so it's hard to characterize its structure. But let's examine some of the basic measurement we usually use to represent the network structure. When we examine each node in this network, we can see that the node connects to different nodes. The number of nodes that a certain node connects to is called the degree of the node. We can obtain the degree of the nodes on the network by calling the function degree. And here we can see that Tom Hanks connects to 2 other nodes, Bill Paxton to 2, and Gary Sinise to 4, and so on and so forth. This basic measurement of position serves to differentiate the nodes. For instance, we can see that Gary Sinise is more central because it has a higher degree. When we look at the degrees in general overall in the network, we get what we call a degree histogram. It's basically the degree histogram telling us how many nodes of each degree exist in this network. So in this network, we can see that there is no node of degree 0. There is no disconnected node in the network. There are 2 nodes of degree 1, basically Kevin Bacon and Ed Harris here. 2 nodes of degree 2, Tom Hanks and Bill Paxton. 0 nodes of degree 3, and 1 node of degree 4. Now this degree histogram, you can think about this as kind of the footprint of the network. This is an overall measurement of the structure of the network. And different networks have different degree histograms. For example, networks that contains a large number of hubs have what we call a power law distribution of degrees. Most nodes have lower degrees, but there are some nodes, very few nodes, that have a very large degree. So we can actually illustrate this degree distribution is many often plotted as a histogram of the degrees. We can do that if we wish. We can create a bar chart using Altair. We can load the data into pandas and create a bar chart using Altair here. So again, this is a small network, so the degree distribution is not very illustrative here, and it's not very important because we have few nodes. But when we have, like, say, for instance, hundreds of nodes, this illustration, this figure serves to summarize the structure of the network. Another measurement that characterizes the structure of the network is called the density. Basically, this is the number of edges in the network divided over the number of all possible edges in the network. If we take a look at our network here, we can see that we have 1, 2, 3, 4, 5 edges. How many edges are possible to have in this network? Well, this network has 5 nodes, so we have 5 times 4 divided over 2 for a total of maximum 10 edges if this network is one big clique. Hence, the density of this network, as illustrated here, is 0.5, which is 5 actual edges divided over 10 possible edges in this network. So this network is not dense, and many often social networks are not dense. They're actually not very dense at all, but they are aspects of the network that have larger density than others. Another measurement that characterizes the structure of the network is the average shortest path length. This is something we looked at last time when we looked at the average shortest path in between different nodes in a network. If you aggregate, if you look at all of the shortest path between all pairs of nodes and you take the average, this is called the average shortest path length. In this example here, on average, it takes us 1.5 hops to go from any node to any other node in the Apollo movie network. Finally, we have the clustering, the average clustering of the network. The clustering of a node is basically the connectivity of the other nodes that happen to be adjacent to this node. For instance, if we take a look at individual nodes, for instance, in this case, Tom Hanks here, we can see that the clustering is 1. If you take a look at this node here, you can see that Tom Hanks has 2 neighboring nodes, Gary Sinise and Bill Paxton, and they're both connected, and hence the clustering is 1. On the other hand, if you take a look at Gary Sinise here, it has 4 adjacent nodes and only 2 of them are connected, which is Bill Paxton and Tom Hanks. Hence, if we take a look at the clustering of this, it would be 0.166 because we have only one possible connection in between these 4 neighboring nodes. That basically tells you how tightly are the neighborhood of certain node in the network. In the example of Tom Hanks, his neighbors are tightly connected, hence this whole thing is clustered together, right? It's basically a clique. Tom Hanks, Gary Sinise, and Bill Paxton, for instance. However, Gary Sinise has many people who are not connected to each other by any other mean except than connecting through him. If we take the average clustering in the network, that basically gives us what we call the clustering coefficient of the network, which is another aggregate measurement of the structure of the network. You can think about this measure as the cliqueness of the network. To what extent this network represents a large clique. And in this case, we can see it's like 43%. It's not cliquey, but there is some cliques within the network as we see here in this kind of large clique as well as this 2 smaller cliques. So those measurements are measurement of the network overall, and they are useful if we're dealing with multiple networks that we need to compare. Now, on the other hand, if we only have one network, we're basically more interested in the structural properties of the node's position within the networks. So we have so far seen 2 of them, the degree and the clustering. There are other measurements that help us understand the position of a node within the network. And those measurements are called centrality because they represent the centrality or how central a node is within the network. I mean, intuitively, if you take a look at this figure, you will say that, well, Gary Sinise is central and Kevin Bacon is not so central. Those measurements seek to kind of add a precise definition of what we mean by centrality. There are a few of them actually, and degree sometimes is called degree centrality. Another one is called closeness centrality. Now, closeness centrality is basically the reflect on the shortest path between the node and all other nodes in the network. The nodes that has the closest shortest path to all other nodes is more central in the network. Now, this measurement is normalized, and hence we can see that Gary Sinise is the most central node in the network compared to other nodes. In this example, for instance, Ed Harris and Kevin Bacon are least central using closeness centrality. Betweenness centrality is also related to this concept of shortest path, but instead of looking at the path itself, it looks at the number of paths that goes through the network. It's closely related to this idea of brokering. A broker is a node that happen to arbitrate on many shortest paths in the network, meaning any communication between 2 other nodes have to go through that broker. Let's take a look at the network again here. If you look at this network, and let's assume, for instance, Kevin Bacon would like to send a message to Tom Hanks, and this message has to go through the Apollo movie network. In this case, there's no way but to go through Gary Sinise in this case. That's the same case for all nodes except Bill Paxton and Tom Hanks because they have a direct link. Which basically say that Gary Sinise kind of arbitrate on all pair shortest path except the shortest path between Bill Paxton and Tom Hanks. And that's what we see here. This node has the highest betweenness centrality. It's not 1 because still Tom Hanks and Bill Paxton have a direct link, but it's the node that has the highest betweenness centrality in the network. This concept of betweenness centrality and brokering has been used thoroughly in social network analysis, and there is evidence that betweenness centrality and brokering also relate to influence, power, leverage in social networks. The two remaining centrality measurements are closely related, the eigenvector centrality and the page rank. And those two measurements relate to, they look at the structure of the network, and they also examine how a node is embedded within the network and connected to other nodes. The page rank, if you've heard about this algorithm, is basically the algorithm that Google uses to rank web pages when you do a Google search. They're basically looking at the web links between the web pages and use the web links to determine the importance of a page within the internet. Basically, a page is important if there are many other pages that point to it. Now that's kind of a first level of looking at importance, but all links are not created equal. Then the page rank looks at the importance of the pages linking to the page in question using the same criteria. So a page is important is if it's linked to from pages which are also important, and they are important if they are looked at, they're linked to from other pages that are important, and so on and so forth. There is some substantial math underneath the hood. It uses the eigenvector of the adjacency matrix to come up with this measurement, but you can think about it as a measurement of influence and importance. You know, think about your resume. People usually provide referees on their resumes to kind of boost their resume, their credibility. But not all referees are created equal. A reference from someone who's not very well known in the field doesn't count as much as a reference from somebody who's well known in the field. And that's the same idea in PageRank, except that being well known or being famous is also calculated using the same criteria by examining the position of the node in the network. Now, once again, if we take a look here, we can see that in this particular example, particular network, all of these measurements kind of give us the same idea, the same understanding of the network, that Gary Sinise is the most central, and then followed by Tom Hanks, Bill Paxton, and at the end, Ed Harris and Kevin Bacon. And that's what we get by looking at the network structure. I linked here to the network centrality measures on Wikipedia. And if you take a look at this figure, you can see that these different network measures will give you a slightly different understanding of the positions of different nodes in the networks. So you can see the difference in between betweenness, closeness, eigenvector, degree, and other kind of centralities by looking at this figure here. For example, you can see that betweenness centrality gives more weight to the brokers, but not much weight to other nodes that are central but not brokering because of the existence of these few brokers. If you take a look at closeness centrality in B, you can see that it gives kind of importance to nodes central to the network, regardless of their brokering power. The eigenvector centrality, which is related to PageRank, ultimately gives weight to the few nodes that happen to be more important by the virtue of everyone kind of linking into them. The degree centrality, on the other hand, doesn't take this global connectivity into importance. As long as the node is connected, that it has many direct connections, it will be kind of highlighted as important. So these different measurements give you different pictures, different understandings of the positions of nodes in the networks as well as the structure of the network overall.